same page here.
All right, so let's go over here, collect some data. Del Taco, half pound bean cheese burritos. All right. Sample of size 30, because we're not talking about a parameter yet. We want to know what the parameter is, right? What is the average weight? That is what we'd like to know, right? We'd like to know that, you know? Maybe Del Taco wants to know, could we market? Could we market a half-pound bean and cheese burrito, right? Could we market that? Could we afford to do that? And, well, that's another discussion in itself. But nonetheless, what's the average weight? So we start collecting data to find out, because we don't know what that is, unsure. We take a sample of size 30. What do we get as summary statistics? I'll do it with you guys if it's okay, if you don't mind. Do one bar stats. This over here. Is this what you guys got? Did I do it correct? Are we close? If we're a little bit off? So how about we call that 0.53 pounds? Is that decent? If we go, you know what? No. 0.526. What the hell? We got 3 decimal places of precision on the scale. Let's use it, shall we? So we get a sample average of 0.526 pounds. Let's slide this, make sure we can see this okay. Looks like we can. And some of us may be off a little bit. That is totally fine. Again, this is why I like to default to using Excel, because you can just copy and paste and drop it into Excel and then go equals average. Yes, David's like, yes, thank God. Yes, and I like to default to that, but in class we only have this computer, so we're stuck with what we've got. So we're done, right? An average weight of a Del Taco half-pound bean cheese burrito is over half a pound. Done. Check, please. No, we're not done. Why? Yeah. Because we ignored the margin of error. Why is the margin of error important? Elizabeth, why?
Because you could have weights on far end side.
Suppose I bought 30 more, which I did. Suppose I bought 30 more and weighed 31s. Am I going to get that again? Right? Am I going to get close to it? Most likely close, right? Most likely close, but not exactly. What if I came down 0.498 and then I'm like, oh God, now it's not half a pound. But that doesn't matter because the 0.498 also needs a margin of error. Yes. So what up here is going to help us with that? Yes, that's the closest thing we have from 243. You got to remember, friends, this is a descriptive statistic. X bar, a descriptive statistic, it only talks about that sample. So does this. Brandon, was that you with standard deviation? Or is it Connor? Is it Connor?
Yeah.
Connor, Brandon, or Brian. Not Brandon. Brandon's up here. Brandon, okay, we're getting there. Lots of B's. Sample standard deviation for this sample is this guy, right? 0.025. 0.025 pounds. That is the sample standard deviation of this particular 30 burrito sample. Would it change if we sampled 30 more? Of course. Of course it would. It would have to. Most likely. I shouldn't say of course. Most likely it would. Maybe just a little bit, but it would definitely change. Excellent. So what do those two things tell us right now? Can we get any meaningful information from those two pieces? Can we do anything with them, do you think? What can we do with those two pieces? This is not as important. This is just kind of like an afterthought, like we sampled 30. Although it becomes important inferentially. But what can we do with just those two pieces right now? What do you think?
You can find out how many are within so many standard deviation of
Music to my ears, Elizabeth. So, if the data is what?
It's the variance, right?
Oh, good. Well, we could call it the variance. I'd rather call it the standard deviation, just because the variance. What would the units on the variance be? When you say in variance, Brian, do you mean variance in the general term of the sway of the data, or variance as in S squared?
Yes,
S squared. What would the units on the variance be? If average is in pounds and S is in pounds, variance would be square pounds or pounds squared. And I try to avoid that, not because I don't like the variance, because as we saw, the variance is an unbiased estimator. It's just that the units don't make any sense with us, like square pounds don't make any sense. So if that's okay, I'd like to use this idea of how many between. What assumption are we making about the data when we say that? Are you thinking Chebyshev? Or are you thinking something more general?
the Chebyshev.
You think Chebyshev? Can we not think Chebyshev? Just because Chebyshev, the problem with it is, it's too general. It says, you know, I can be 100% confident there's at least nothing within one standard deviation. I'm like, thank you, you crazy Russian. That doesn't help me a whole lot though, right? But we do have percentages that we like. We've been talking about all class. You can talk about it at the end of 243. This 95% that keeps coming up. What does that tie back to? 95%. What does that tie back to? Two standard deviations. Where? On either side of the mean, where?
Standard bell curve?
And if it's a bell curve. That's an if though, right? Let's look. Let's see what the data's shaped like, okay? Because I like using, Chebyshev is great because it works anytime. It's so general though that it doesn't give us a whole lot of specificity. But if we can say this data is bell-shaped, then we can go even, you know what I'm saying? We can get even closer into. All right, so let's take a look. Remember how to make histograms? You can say no, it's totally fine. You can go, you get it. Ah, it's totally fine. So, second, y equals. Plot 1, enter. Turn it on, please. Turn it on. Please turn it on. Select the histogram, which is this guy right here. Boop. Where is your data? List 1, yep, mine's in list 1. My frequency is set to L2, but it shouldn't be. It should be set to, do you remember this from 243? It should be set to the number 1, which means count all of the data in L1 one time. The problem is if you type 1, you get this letter Y. This is a bug I wish TI would fix, they never do. It's stuck in alphabet mode right now. You see that little A on the blinker? It's stuck in your alpha mode. So press the alpha button and then press 1. And this is what you should be looking at when you have raw data. Your data is in L1, use each one of them one time. Now we're going to make a histogram for that. Cool, we'll do this lots and lots as we go through the course. So if it's not coming back to you right now, we'll keep doing it. I found the easiest way to now get the graph is to press Zoom 9. Zoom 9 is the zoom stat, it's going to fit the window to your data. So Zoom 9, there it is, okay? I also like finagling with the window. I'm not a huge fan of leaving it exactly as the TI decides it should be. I like to mess with it a little bit more. So this is my personal opinion, you can totally ignore this. This has actually been where your .489 to .589 comes in handy. It gives us an idea of what the breakdown should be. It's set in the minimum to .489, and then it's scaling up to 6.0 with a scale of .016, which is a very strange number. I don't know why they picked that. I think it's this minus this divided by 7, but I'm not entirely sure. So mess with it. Let's mess with it. I'm going to make the bottom be, .489 is fine. I might round it down a smidge to .45. Make this guy go up to .65. Just to make the numbers a little bit, whoops, .45, delete, .65. And then, let's see, if I want, I can scale it by .025 maybe, or .015 or something like that. Let's see what this looks like. Okay, it's not high enough. We can now change the Y max if you want to, or we can make more bars by making this a little bit more narrow. Okay, we're getting see what we're doing? We're just refining the graph to try to get more of an idea of its shape. I'm kind of liking the idea of making more bars than making the graph higher, because then we're going to get a little more refinedness of the data. Okay, maybe make this .015. My initial gut feeling was to go that way. Oh, look at this. See, all I'm doing is messing. You do this too. I'm just changing. See, I hit the window button. That's what I'm messing all this with, the window button. You can do this in Excel. We're going to learn how to do this in Excel as well, of course. Then go!
Well, why would mine be drawing a line infinitely across here?
Oh, it's still drawing, isn't it? Press your on button first. You have to break it. Now press your Y equals button. Guess why? Take that L1 out of there. Yeah, you don't need it in Y1. What would it be doing? I'm not even sure what it's doing, to tell you the truth. It's trying to graph the data horizontally, maybe? Huh? I don't know, but it'll stop doing it now. Oh, no, you got it. And you can keep messing with this. Now, there is a limit. If you mess with it too much, the TI will get pissed eventually and say you're trying to make too many bars. Let me see if I can illustrate that for you. Is 01 okay? No, 01's okay. If I make it too small, though, it'll be like, too many. Okay. But that's okay, because honestly, what was the only reason I was doing this for? Do you remember? I wanted to see if this was arguably bell-shaped data. What do you think? Arguably bell-shaped data? I think it's close. There's not too much skew on this. Good. Ben's like, I could go either way with it. Good. It's a small sample, which means we have to accept a little bit of high variability. If you want, you can calculate the skew, but if I remember correctly, nobody in 243 liked that very much. No, it's like, this is one thing I remember and I didn't like. That's okay. But the idea is that's Bell-ish. I've got more tools in 243 to help you decide. When we look at the BP oil spill data, there's a great thing called a quantile plot. We'll get that in time when we need it in a few weeks. But I think this is okay as far as Bell. It's small. It's a small data set. It's a little bit noisy. But I see those key characteristics of a bell shape. I see a larger hump in the middle tailing off. Sure, some of the tails are missing. That's totally fine. Some of the tails are missing, but I still see, what I don't see is something like a U shape. Or a crazy tail extending out this way. Yeah, I got this little hiccup here. But there might be a hiccup over there we just haven't seen yet. Gesundheit. So I'm tempted to go ahead and call it a bell curve. You can err on the side of calling it bell curve with this distribution. You'll see why momentarily. Okay. So now that we know that, what can we do with this? Now that we're like, yes, it's a bell curve. What can we do with that?